1, go.
Good morning, everyone. We're back again. We're doing mathematics, grade 8. My name is Andile Zondi. We are continuing where we left off yesterday. But before we continue, we are allowed to ask questions. So if you don't understand, please ask questions using the chat, but reference your questions. So don't just say I don't understand. Say I don't understand question 1A, or I don't understand activity 1B, right? So when you ask questions, please do that, so that it will be easy for me to answer your questions for you, right? Okay, today I'll give you guys an opportunity to ask questions, and I'll answer them after each and every activity, right? Okay, so let's start. Okay, for today's lesson, we're looking at using commutative, associative, and distributive laws to determine squares, cubes, square roots, cube roots of single algebraic terms or like terms, right? So basically, long story short, we're looking at squares, we're looking at cubes, we're looking at square roots, and we're looking at cube roots, right? So obviously, when I say square, I actually literally mean a square. That is a square. Square has 4 equal sides, right? And then when I say a cube, I actually mean a box with all sides equal. That will be a cube. Okay, so this is a cube. Okay, obviously all of the sides in this cube, they're all equal sides. Okay, let's say I have a small cube. Let's say this cube, this square is 1 centimeter length and 1 centimeter width. Okay, so the area of this square, right, it will be 1 centimeter times 1 centimeter. 1 centimeter times 1 centimeter. Obviously, 1 times 1 is 1. Centimeter times centimeter is centimeter square. Right? So basically, 1 centimeter square is a square, right? So this is what you call a square. Right? So when I say a square root, I basically mean what was 1 centimeter squared before it was squared. Obviously, it was 1 centimeter. Right? In other words, a square is a number that you multiply by itself, right? A square root, you're basically looking for the original number. What number did you multiply by itself to get a square? So that will be a square root. So in this case, this is a square root. Okay, I know that maybe this may be new to some of you. I'm sure some of you did this last term, right? So whether it is new for you or not, you guys will be able to catch up. So this is a square root, right? Okay, so same thing applies to, let's say I want to know the cube of this, right? In other words, this will be a volume. This is area, by the way. Area. Now let me deal with the square. Let me just change color. Let me use yellow for now. I'm done with the square. I'm now looking at the cube, right? Okay, so remember all the sides are equal. Let's say this is, for example, 1 centimeter. It could be anything. By 1 centimeter, right? By 1 centimeter. So all of the sides are 1 centimeter each. Okay, so if I want to know the volume of this, which is the cube, I'll say 1 centimeter times 1 centimeter times 1 centimeter. Right. Okay, centimeter times centimeter times centimeter. The answer should be centimeter cubed. This is a cube, right? Obviously, 1 times 1 times 1 is 1. You can leave it out or can write. We usually leave it out in maths. Okay. So 1 centimeter, this is a cube, right? How did you get a cube? You multiplied a number by itself 3 times to get a cube, right? So this will be a cube. Notice this is a cube, by the way. For square, this is a square, by the way. Okay. Basically, I'm just showing you how this applies to real life. Now, if I want to know a cube root, basically want to know which number did I multiply by itself 3 times to get 1 centimeter cubed. Obviously, the number was 1 centimeter. I multiplied 1 centimeter by 1 centimeter by 1 centimeter. So 1 centimeter in this case, that is cube root. Okay, I'll go over this again. So this is just an introduction, so that you know how everything fits. Okay, so next introduction, a square. A square is a number that you get when you multiply a number, when you multiply this number by itself twice. So this is twice. Or you multiply it by itself once, depends how you view once or twice. For example, 4 multiplied by itself once, right? Or multiply 4 by 4, right? Depends how you view once or twice. Basically, 4 times 4 is 16. So 16 is a square, right? 16 is a square number, right? A square root, basically, in this case, you want to know which number did you multiply it by itself, right? To get your answer. Which number was it? In other words, a square root is a value that that multiplies by itself once to give the original number, right? Obviously, 4 times 4 is 16. Okay. In other words, if I want to know the square root of 16, I want to know which number did you multiply it by itself, right? Once, right? To get 16. That number was 4. So the square root of 16 is 4, right? Okay. We'll look at examples later. So should you have questions, just hold them for now. Okay, now let's look at cube number. Okay, this is a number that you get when you multiply, when a number is multiplied by itself twice, or in other words, a number that multiplies by itself twice. If you have 3, you multiply 3 by 3 twice, 3 times 3 times 3, or 3 multiplied by 3 times. Okay. I like to use the 3 times one. So it's 3 times 3 times 3, right? You get 27. Okay, so 3 times 3 times 3, 27. Obviously, this can also apply to variables. You can have x times x times x. So x times x times x. Remember, when you are multiplying a base, right? Same bases, the powers must add. So the power is 1 plus 1 plus 1. So the answer will be x to the power 3. Right? If you're looking at 2, it will be 2 cubed. Will be 2 times 2 times 2. Okay, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay, so this is a cube, right? Cube number. So this is a cube. (27) is a cube. X to the power 3 is a cube. Okay, cube root. This is a value that multiplies by itself 3 times to get the original number, right? So in other words, 3 times 3 times 3 is 27. This is a cube, right? You want to know which number multiplied by itself 3 times to give you 27, to give you a cube, which is 27. Obviously, that number was 3, right? 3 multiplied by itself 3 times 3 times 3 times 3, right, to give you 27. So the cube root of 27 is 3. By the way, this is how you write cube root, or cube root, right? A square root will be basically, we don't write it 2 for a square root. So this will be, we don't really write it 2, but this is a square root. Square root. Okay, let's carry on. Okay, just go over this lesson again, right, so that you understand exactly what is happening. Okay, here are some misconceptions, right, that learners have problems with when they deal with square roots. Okay, let me change my color to red. Okay, here it says the square root of a product of square numbers is equal to the product of the square roots. In other words, this is what I mean. If I have two numbers that are multiplied, right, a product, right, the square root of these numbers, right, is the same as saying a square root of each. Square root of each. For example, 25 times 9. Learners, what is 25 times 9? Just use your calculator and tell me what is your answer. 29 times 9, right? My answer is 225. So this is equal to 225, right? 25 times 9 is 225, right? So what is the square root of 225? In other words, which two numbers do you multiply by themselves to get 225? So square root of 225 is 15, right? This is the same as saying square root to get 225, 15 times 15, right? So the square root of this is 15, obviously. Okay, if you're not sure, you can just use a calculator for this one. Okay. Here, I'm trying to show you that this can be written in this format. Let me use a different color. Just use blue because I'm doing the other side now. Let's say now I'm looking at this side, right? The square root of a product, the square root of 25 times 9 can be written as the square root of 25 times the square root of 9, right? What is the square root of 25? In other words, which two numbers did I multiply to get 25, right? Obviously, to get 25, I multiplied 5 by itself once. 5 times 5, right? So your answer, square root of 25, answer is 5, right? Times, what's the square root of 9, right? Square root, which two numbers did I multiply by themselves once to get 9, right? Those numbers was 3 times 3. 3 times 3 gives you 9, right? So the square root of 9 is 3. So 5 times 3 is 15, right? Notice it's the same, right? It's the same both ways, right? But now here is the misconception. Now learners tend to think that this method applies to addition, right? Whereas it does not apply to addition, right? This does not apply to addition, right? What do I mean? Okay, the square of the sum, remember sum is the answer you get by adding, of square numbers is not equal to the sum of the square roots. What do I mean by that, right? I basically mean if I have a square and I'm adding two numbers, okay, 25 plus 9. What is 25 plus 9? Answer is 34, right? Okay. The square root of 34. If you're using a calculator, okay, for this one you need a calculator, right? Okay, let me just take out my calculator. Okay, the square root of 24. Give me some time. So the square root of 34 is 5,83, right? So the answer here will actually be equal to 5,83. 5,83, right? Okay, now notice it is not equal to the square root of each individual number below the square root sign. For example, what is the square root of 25, right? Obviously, you've done it here. The square root of 25 is 5, right? Square root of 25 is 5. What's the square root of 9? The square root of 9 is 3. Okay. Now, add these two. 5 plus 3 is 8. Now, notice 8 is not the same as square root of 34. Square root of 34 is 5,8. So 8 is not the same as 5,8. Right? So that's why I said this is not true. Right? It's not equal. Okay, that is the first misconception that learners have. Okay, the next misconception is the following, right? Here it says the square of the difference. Remember, difference is the answer you get when you subtract values of square numbers is not equal to the difference of the square root. Okay. In other words, square root of 100 minus 34 is not equal to square root of 100 separately minus square root of 64, right? These two are not equal. Okay, let me prove it. Let me prove it for you. Okay, 100 minus 34. What is 100 minus 34? Answer is 36, right? Okay, what is the square root of 36? Okay, which number did you multiply by itself once to get 36? That number was 6. So 6 times 6 is 36. Here the answer is 6. Okay, it's not equal to square root of 100 minus square root of 64. Okay, what is square root of 100? Right? Which number did you multiply by itself once to get 100? This was 10. 10 times 10 is 100. So the square root of 100 is 10. Minus, okay, subtract difference. For square root of 64 is 8, right? Square root of 64 is 8. In other words, 8 times 8 is 64. Right? 10 minus 8 is 2. 2 is not equal to 6, or 2 is not equal to square root of 36, right? Okay, that is the next misconception. Okay, but this is true. The square root of a quotient is the answer you get from dividing, of a square numbers is equal to the quotient of the square root. In other words, square root of 81 divided by 4 is equal to square root of 81 divided by square root of 4, right? Okay, let us prove that. Okay, square root of 81 divided by square root of 4, right? Square root of 81 can be written as 9. Remember, 9 times 9 is 81. So what was 81 before you squared it? It was 9, right? Okay, what was 4 before you squared it? It was 2. Remember, 2 times 2 is 4, so it was 2. So here the answer, 9 divided by 2 is 4,5. Okay, now let's check whether this is equal to this. Let me just use a different color for that. Let me use red. Okay, for this I'll be using red. I want to write it here. Okay. Square root of 81 divided by, okay. Here, what is 81 divided by 4? 81 divided by 4, right? What is your answer, right? 81 divided by 4. Okay, my answer, if I'm using my calculator, my answer is 20, 25, right? 81 divided by 4 is 20, 25. What's the square root of 20, 25? Answer is 4,5, which is the same as saying 9 divided by 2. Okay. Last misconception, right, that learners have when it comes to this type of questions, right? In fact, we've already done this here, right? If you have this question, square root of 25 x squared minus 9x squared, right? Right. You can subtract these two because they are like terms to get 16x squared. And the square root of 16 is 4. The square root of x squared is x, right? Remember here, to get 16, you can say 4 times 4. And to get x squared, you can say x times x. So this is the correct answer. This is wrong. You cannot, when you subtract, you cannot get the square root of each number individually. You cannot say the square root of 25 is 5, square root of x squared is x, right? Minus, you know this is correct and this is correct, but you cannot do them separately if you're subtracting under the square root sign. So same as here. Okay, now let's look at activities, right? Okay, my introduction for today was very long, right? Let's look at activities. Okay, activity 1, right? Determine the value of each without using a calculator. Here, a K is without using a calculator, right? What is the square root of 25? In other words, which two numbers did you multiply by themselves or by itself once to get 25, right? I'll give you guys 20 seconds for A. 20 seconds for A, right? It's easy.
Teacher?
I'm giving you 20 seconds. Yes?
Sorry to interrupt, but I've got a couple of questions.
Okay. Go ahead.
Please do the square root again from 7 of your learners.
Square root again.
5 of your learners asking, and cube roots.
Oh, okay. To redo them.
Yes, please, sir. Explain again. They do not understand.
Okay. Can I explain using the examples? Let me explain using the examples because okay, these misconceptions are, I'm using big numbers. Let me use these examples to explain cube roots and square roots. I think it will be easier, right? Okay, I know this section is a bit difficult, but learners, I'll use these examples to explain square root and cube root, right? Okay, for a square root, right? Okay, what's the square root of 25? In other words, I want to know which number did you multiply by itself once to get 25. So this can be written as square root of, okay, to get 25, I can multiply 5 by 5, right, once. And then obviously to get 25. So which number did I multiply by itself once to get 25? The answer is 5, right? Remember, when I say roots, I mean the beginning, right? Roots, think of a tree. The root is always at the bottom, right? So which number did you multiply by itself twice to get 25? That number was 5, right? That number was 5. Okay. Let me give you another example. Let's say I want to know the square root of 36, right? Square root of 36, right? Which number do you multiply by itself once to get 36, right? Okay, it's not 2 times 2 is 4. It's not 3 times 3 is 9. It's not 4 times 4 is 16. It's not 5 times 5 is 25, but it is 6 because 6 times 6 is 36. So, right, if I square 6, I get 36. Remember, these are actually opposites, right? 6 squared is equal to 36. Right? That's why I say, right, if you want to know the square root of 36, basically you want to know which number did you square before you to get 36. Which number do you square to get 36? That number is 6, right? Or which number multiplies by itself once to get 36? That number is 6, right? So that's how you do square roots, right? Now let's look at cube roots. Okay, cube roots, basically the question here, what is the cube root of 64, right? I'd like to know which number did I multiply by itself, right? Or which number multiplied by itself twice to get 64, okay? Or which number do you multiply by itself 3 times? Okay, I don't know. Okay, I think when I say 3 times, it's easy for learners, right? Which number do I multiply by itself to get 3 times to get 64? Okay, let me try 1. It's okay, it's not 1. Let me try 2. 2 times 2 is 4 times 2 is 8. So it's not 2, right? I don't multiply 2 by itself 3 times to get 8, right? Let me try 3. 3 times 3 is 9 times 3 is 27. So it's not 27. Okay, let me try 4. 4 multiplied by 4 multiplied by 4. No, I'm doing this 3 times because I'm looking at cube roots, right? So 4 times 4 times 4, answer is 64, right? You can just use a calculator to verify that, right? So which number did you cube to get 34? Which number did you cube to get 34? So you cubed 4 to get 64, right? So the correct answer here, the root, the beginning, it was, before it was cubed, it was 4. Hopefully that makes sense, learners, right? Okay, when I say, let me revise this, right? When I say I want to know the cube root of 64, I want to know which number did I cube to get 64. So I cubed 4 to get 64, right? In this case, when they say don't know the square root of 25, basically which number did I square to get 25? That number was 5, right? Hopefully you guys understand these two examples. Let me do one last one, just because you're special. What is the cube root of, remember, cube root is written with the 3 of 27. Basically here, in simple terms, I want to know which number did you cube, right, to get 27? Which number did you cube to get 27, right? Obviously, 2 cubed is 8. 2 times 2 times 2 is 8. But 3 cubed, 3 times 3 times 3 is 27. Which number did you cube to get 27? It was 3. You cubed 3 to get 27, right? Hopefully you learners understand that, right? Okay, maybe before I continue, let me check if there are any questions based on A and C. Producer, are there any questions based on A and C?
Sir, no questions, but please slow down. Your learners is
Okay.
asking to slow down.
Okay, I will do. Will do. Okay, now learners, I want you to do B for me. Please do B for me. I'll give you 1 full minute to do B. Right? What is the square root of 144? Right? What is the square root of 144? Okay. I'll try to slow down as best as I can, but please give me the answer. In other words, which number did you square to get 144? Which number did you square to get 144? Okay, 30 seconds left. 20 seconds. Okay, maybe I should give you just not few couple of seconds because I may be moving too fast for you. Okay, just compare your answer to my answer, right? Here, what I want to know is which number, right? Which number, right, do I square to get 144? Basically, this is what they want. Which number do you square to get 144? Right? In other words, which number that multiplies by itself once to get 144? So obviously, you need to know your tables, your times tables, right? Okay, in this case, if you've forgotten, it is 12, right? 12 times 12 is 144, right? 12 times 12 is 144. So which number did you square to get 144? It was 12, right? So your answer here is 12, right? Your answer is 12. Which number did I square to get 144? Well, the square root of 144 is 12. Okay. I want you learners to now attempt to do D. Then I'll take your questions if there are any questions, right? What is the cube root of 216, right? In other words, which number did you cube to get 144, right? Which number, I'm just giving you a clue here. Which number do you cube to get 216? I want to know this value. Let's write this value without the cube. Just write this value by itself. Okay, in this case, just to simplify your life, you can just try to use a calculator to see which number multiplies by itself twice or 3 times. Which number multiplies by itself 3 times, 1, 2, 3 to give you 216, right? Which number multiplies by itself 3 times to give you 216, right? Giving you a couple of seconds. So I don't want to rush you because this is not easy for most learners, even in my class. Which number multiplied by itself 3 times to give you 216? Okay, obviously, you can just do trial and error. Okay, we've done 4 cubed is 64. 5 cubed is 125. 5 cubed. 5 times 5 times 5. Okay, let me erase because there's too much. Let me just erase this. Okay. And let me continue writing. Okay, so 4 cubed is 64. 5 cubed, this is like saying 5 times 5 times 5, which is equal to 125. Right? So the cube root of 125 will be 5. Now let's try 6. 6 cubed. 6 times 6 times 6. Right? 6 times 6 times 6. So 6 times 6 times 6. Lucky for me, the answer is 216. 6 times 6 times 6, answer is 216, right? So the cube root of 216, right, is 6, right? Answer here is 6. In other words, the number that I cubed to get 216 is 6, right? Let me before I continue, learners, let me check if there are any questions. Producer, are there any questions based on activity 1?
Sir, there's one question.
There's one question, okay? Continue, please. Okay, I can't hear my producer. I might have.
Teacher.
Yes.
Teacher, is this
I can tell you now.
Is this first term work?
Yes, this is actually term 1's work, right? Learners, most of you did this in term 1. Just that now I'm combining it with algebra, right? So this is term 1's work. I'm combining it with algebra. So for some of you, this will be easy. For some of you, it will be difficult. So this is term 1's work. So that is correct. Let me continue.
Sir,
Yes?
sorry, second question is, when are you going to mark yesterday's homework?
Oh, okay. That is a good question. Okay. I think, okay, direct to me. There's my email is Andile at Lockdown School. Okay, maybe tomorrow I'll give the learners an opportunity to send through. I'll give learners my email so that they can, for the Lockdown School, so that they can send me their homework, right? So that I can mark work for today and for tomorrow as well, right? Maybe sorry about that. I'll have to. In fact, I was supposed to give you guys answers to yesterday's work today. So sorry about that. Right? Are there any other questions? Okay, no other questions. Okay, so let me continue. Right. Okay, learners, remember the reason why we're revising term 1's work is because term 1 we're not dealing with algebra. Well, there were no x's, right? There were no a's and b's and y cubed and so on, right? But term 2, because we're looking at algebra or algebraic expressions, we are now mixing term 1's work with term 2's work, right? Okay, now learners, I need you to give me the answer for A, right? Give me the answer for A, right? Remember, term 1, we're looking at numbers, but here, term 2, we're looking at variables as well, right? Numbers and letters. Okay. Okay, what is your answer to 1? I'm giving you a couple of seconds, right? Okay, probably this will be my last activity for the day. And then I might just give you guys homework as well. Okay, 1A. Learners, by the way, you can also ask your parents to assist you with homework. Right? You can also ask your parents, but I'm willing to mark your work. I'll give you guys my email tomorrow for the lockdown school. Okay, what is your answer? Square root of x to the power 12. What is your answer, learners? I'm sure that most of you are done, right? In other words, I want to know which term did I multiply it by itself to give you x to the power 12, right? Okay, yeah, your answer should have been, okay, your answer should have been the following: in x to the power 6 times x to the power 6. So x to the power 6. So the square root of x to the power 12 must be x to the power 6, right? That is your answer. That is your answer, right? Okay, let's look at B, right? Okay, B is a bit long. Let me give you learners two minutes to do B. Let me give you learners 2 minutes to do B, right? Okay, here I'm giving you a right to use calculator for these big numbers. You can use a calculator for these huge numbers. 125 and 44 are big numbers, so you can use a calculator. So I want to know what is my answer. I'm giving you 2 minutes, right? You have about 1 minute and 30 seconds left, right? So work as fast as you can. I'll wait for you.
Teacher,
Yes,
I've got a question that says,
I'm listening.
Sir, I don't
Yes.
know how to calculate with a variable. Please explain before the end of the class so I can study.
Okay. Okay. In fact, these questions are all linked with variables. So as I'm going through these questions, the learner will be able to understand how to calculate variables. Right? But that's a very, very good question. Because if you're using numbers, this will be easy. Let's say square root of 36. Here, which number did you square to get 36? The number was 6. So when it comes to variables, x squared, right? Which number did you square? Which variable did you square to get x squared? You squared x, right? You squared x. Okay, let me give you another example. If you're using numbers, what is the cube root of 125? In other words, okay, we've done this before. Which number do you cube to get 125? Which number do you cube to get 125? That number, if you still remember from the previous slide, that number was 5. So you cube 5 to get, right? So this is the cube root of 125. Let's say I'm using, what is the cube root of y cube? Okay. Which variable did I cube to get y cube? Which variable did I cube to get y cube? That variable must have been y. You cubed y to get y cubed, right? So hopefully that explains this work, how these work. Okay, your time is actually almost up for. Okay, so for B, let us do it together. Now, since we are adding, right, we need to cannot separate this. Like you cannot say square roots of 125 x squared plus square roots of 44 x squared, right? But what you can add both. So your first step here will be your square root 125 x squared. Remember, these are like terms. These terms are the same because they both have a type. So you can say 125 x squared plus 44 x squared. So obviously in this case, 5 apples plus 3 apples is 8 apples. So this stays the same. Surname stays the same. And then 125 plus 44, your answer is 169. I said you can use a calculator for this one, right? 169, right? And then what is the square root of 169? In other words, which two numbers did you multiply, or which number multiplies by itself, right, to get 169, right? Obviously, that number was 13, right? Was 13 times 13 is 169. Likewise, x times x gives you x squared. So in this case, your answer will be 13x. Answer will be 13x. Okay. Actually, I don't have much time, but I would like to do this question for you with you. Right? I'd like to do this question with you, but I don't have much time. So I'll give you C as an example. Then I give you guys homework. Then we are good to go. Here I'm looking at the keywords, right? Okay, which number did you cube to get negative 27, right? Okay, this one is a bit tricky because this is a negative, right? But if you recall, a negative times a negative is a positive times a negative is a negative. So this must be a negative number, right? Negative, right? So let me just do this step for you so you can see. So negative 3, right? Say space, I'm using dots for times a negative 3, which is positive 9, times negative 3, right? Which is negative 27, right? And when it comes to x times x times x times x times x, right? So which number did you cube to get negative 27? X cube must have been negative 3x. Okay, now learners, our time is actually up, right? Okay, this one, okay, I can't really give you this one because we haven't. Okay, we might look at this tomorrow. Homework. Okay, this homework may be a bit difficult. Okay. Okay, please do for me for homework number 2 and number 3. Right, for homework, please do number 2 and number 3. Right. Okay, I'll try to answer these questions in tomorrow's lesson before we continue. Right. I'll try to answer this question in tomorrow's lesson before we continue. Okay, but in fact, we actually are of time now. Please write this down as quickly as you can. Otherwise, just screenshot this activity.
Changes are happening.
Sir, I still
Yes.
have 2 questions for you that I think is important.
Okay, please go ahead.
A couple of children say, sir, where does the 6 come from in A? Is it because of 12, half of 12?
6 in A.
Yes.
Okay, let me try to see which 6 are they talking about. Are they talking about this 6?
Yes.
That is a leading indication of
Okay. Let me erase this. Okay, basically, learners, square root of 36. Here, I want to know which number multiplies by itself once to give you 36, right? So that number
Yes,
was
dear.
6. So times 6 is 36.
Sure.
So yes, I'm listening. Producer, I'm listening. So in this case, learners, you don't have anything, right? You don't have anything, right? You just ask yourself, which number do you square to get 36, right? Remember, learners, 6 squared is 36, right? So if you're going backwards, square root of 36 will give you 6, right? So I think that will help you, or that might help you. Producer, is there? Please give me the next question.
Yes, sir. Sir, if we come across exponents in square roots and cube roots, does the law of exponents apply to the exponent as well while working out?
Oh yes, the laws of exponents apply to exponents as well, right? So they do apply, right? So this is very much true. Right? For example, let's say x times x. Okay, let me just say it's x times x times x. Okay, according to the laws of exponents, we're actually adding here powers of 1. So x and x and x, because it is the same, right? So the base will be x. The powers, since you're timesing, the powers will be added. So 1 plus 1 plus 1, answer will be 3, right? So they do apply. They do apply. Even if you have, for example, x squared divided by x, right? Before you carry on, you can actually simplify this by using the laws of exponents, which say if you're dividing similar bases, you subtract the powers. So in this case, it will be x to the power 2 minus 1, right? So your answer will be square root of x. So they do apply, right? Okay, very, very good question. Are there any other questions, or are we done for the day? Are there any other? Yes.
Sorry, we've got another couple of questions on the same activity. Sir, we do not understand B. Could you please also explain B? We've got another 7 minutes if you wish to go on.
Okay, I can explain B to the learners. Let me explain B to the learners. Okay, let me first clear the screen, but hopefully the learners do understand. Okay, now for B, okay, if you recall, learners, a couple of slides back, when we're looking at misconceptions, right? Let me just go back here. Okay, here I actually said, if you're adding two terms which are under the square roots, right? You cannot separate them out, right? Because your answer will be wrong. You cannot separate them out, right? So if they are like terms, you can add them. Like 25 plus 9, you can add these because these are alike, right? So when it comes to B, 125x squared, right? Notice x squared plus 44x squared. These are the same, right? These are the same. This is like saying 1x squared plus 2x squared. So 1x squared plus 2x squared because we're adding, we don't change our variables because we're adding, right? So 1 plus 2 is 3. 3x squared, right? Like saying 1 banana plus 2 bananas. Answer will be 3 bananas. The word banana does not change, does not become banana squared because you are adding. So same thing applies to this question. Okay, let's redo this one here. Right? So square root of, use your calculator. What is 125 plus 44? 125 plus 44. My answer was 169. 169, right? Obviously, they're the same name. Like Jones plus Jones, you have 2 Jones, right? So you don't have a Jones squared. In this case, same thing applies, right? Okay, but now you need to do this separately. You need to find out the square of 169 separately. How do you do that, right? Okay, which number multiplies by itself to give you 169? Which number multiplies by itself to give you 169, right? Okay, in this case, I know that 10 times 10 is 100. 11 times 11 is equal to 121. 12 times 12 is 144. Learners, you need to know this by heart. And 13 times 13 is 160. So in other words, 13 times 13 gives you 168. Right? So the square root of 169 is 13. Okay, now same thing applies to the x, right? Okay, which variable did you multiply by itself to get x squared, or which variable did you square to get x squared? Obviously, in this case, it must be x. X times x is x squared, right? So what was x squared before it was squared? It was x. Okay, hopefully that helps you learners, right? Hopefully that helps most learners, right, with this question, right? I know these are not easy, so you need to practice. Practice makes perfect, right? If I were you, I'll just redo today's questions as they appear, right, to see if I'm getting the same answers that the teacher got, right? Okay, producer, are there any other questions, or should I close the session?
Sir, you can close off your session.
Okay. So learners, if you are tomorrow, you might have this. If you're able to, please write these questions. But I don't know if we'll have time to write these questions because I'm actually out of time for today's lesson, right? But these are very, very good questions to do on your own, right? This one, you just need to say it's true or it's false, and then just solve 3A and 3B, right? 3A and 3B. Tomorrow, before we start, I'll give you guys answers to these questions. And then, okay, misconceptions. You need to remember what you started with, right? You need to remember these misconceptions here, right? Multiplication and addition, right? You can't solve them the same. Likewise, with subtraction and division, you cannot solve them the same. Those are misconceptions that learners struggle with. Other than that, tomorrow we'll look at substitution, right? Substituting numbers into variables, right? And obviously, for more information, you can visit our website, which is www.africatingigs.co.za, right? You can also catch us on Facebook and YouTube. Okay, guys, I'll see you guys tomorrow. Same place, same time. Thank you very much. Bye.